Welcome to section 5.4, everybody. This time we're going to be talking about trigonometric ratios and the unit circle. More specifically, section's chapter is trigonometric functions of real numbers, but I like putting it on the unit circle because there's a lot of connections here now between what we do with our trigonometric functions as we've defined them so far and the unit circle. So first of all, let's define what is a unit circle. I hope you remember this. A unit circle is a circle that is very specific. A unit circle has a radius equal to 1. So if we have a circle, the radius of that circle is equal to 1, and we place the center at the origin. So on our x and y axis, we're going to put our center at the coordinate point 0, 0. We know that we have a very special circle. We call this the unit circle. And lots of our definitions can be attached to this unit circle and will help us to define our trigonometric functions when it comes to graphing them later on. So what was specific about this particular relationship was that it's the kind of circle that for any coordinate point x, y that falls on the circle, in this particular unit circle, if the radius is equal to 1, then it is always the case that the square of x plus the square of y is equal to 1. And we certainly know, we might remember from earlier on that we talked about equations of circles with some other center and some other radius where x minus h squared plus y minus k squared equals r squared. So what we're telling you right here is that since r is equal to 1, the square of the radius is also equal to 1. And that's another thing that makes this sort of a special relationship for us. So a unit circle is the kind of circle that has a radius of 1 and its center at the origin. That's it. That's our basic definition. Now, how do we use that? Well, in general, whenever we have circles, if we have some point xy that we draw in this circle such that one vertex is placed at the origin, 0, 0 right here, and the other vertex is placed at some point xy on that circle, right? There are a few things that we could say. First of all, x is the distance along the horizontal edge of that right triangle. Y is the vertical distance from the x-axis to that coordinate point. Of course, r is the radius. Now, we can define our trigonometric functions just in terms of this right now if we associate it with an angle theta inside of this circle. So if I take my coordinate point 0, 0 right here, it's and I'm going to move x down here so that I can fit all this in. Here's 0, 0, by the way. If I associate this with some angle theta within that circle, I could certainly tell you, well, the sine of theta is y over r, right? And we can define some of these trigonometric functions in terms of that angle theta in terms of the opposite side and the radius, or the cosine of the angle in terms of the adjacent side and the radius, right, which becomes our hypotenuse, and the tangent of the angle, which becomes y over x. Okay, so we could certainly define these things, but since we're dealing with a unit circle, everything becomes a little bit more, well, special. In the unit circle, the radius is equal to 1. So if we have a radius of 1, how does that change things? Well, there's one other aspect of this unit circle I guess maybe we should talk about. That is this, the arc length. What is it about the arc length that makes it special? Well, if we have a central angle theta and we have an arc length s, if the radius is equal to 1, then we know that within a unit circle, s is equal to theta. Right? So when we have that arc length is equal to the central angle, then we're going to replace s with the letter t. So t is going to be specifically, t will be the arc length on a unit circle. So I've got my unit circle below here. And so this arc length right here is t. And so in this circle, we're going to equate it. We're going to say t is the angle theta, right? And t is the arc length on the unit circle. So what does that mean? I can rewrite my trigonometric functions in terms of that arc length. And I could tell you that the sine of the arc length t would be the same as the sine of the central angle theta, and since r is equal to 1, that's just simply equal to y. What's more, we can say that the cosine of that arc length t is equal to x. Again, remembering that t is equal to theta and r is equal to 1. So, of course, tangent stays the same. Tangent of t would be y over x because that's opposite over adjacent. But we could also say that the cosecant of t is 1 over y. It's the hypotenuse over the adjacent of the opposite side. We could say that the secant of the arc length t is 1 over x. And we would define the cotangent of t to be defined as the ratio x over y. Okay, so let's use those here in our next video to define something called a wrapping function and what that means. More to come.